This problem deals with the Golden Gate Bridge in San Francisco. So here's the first part. The important parts are that the road across the bridge is about 246 feet above the water level, and the two towers are about 746 feet above the water level, and are about 4,200 feet apart. Alright, and the lowest part of the parabolic cable is 10 feet above the road. So noting that past information, we can label this. We know that because this entire length here is 746 feet, and this part right here, well, it says here that the road across the bridge is 246 feet. We know that the towers themselves must be about 500. It says that the lowest point of the parabolic cable is 10 feet above the road, so that's about here. And that the distance between these is 4,200 feet apart. So we have to state the coordinates of the top of each tower. If you notice right here, they've placed the origin at the top of the left tower. So the origin for the left tower is going to be a 0 and 0. The coordinates for this particular tower right here, well, we have to keep in mind that this is 4,200 feet away along the x-axis. So it's going to be 4,200 and 0. Because it's at 0 on the y. So in B, what we have to do is the equation of the function representing the parabola can be written in the form y is equal to a, x minus m, x minus n. Use the points in A to determine values for a, m, and n, and show that the equation is this one right here. It'll probably be helpful to figure out the vertex before we go any further. Well, we know that the vertex is going to be the middle part of that parabola. So we know that the x is going to be about 4,200 divided by 2. So x is going to be about 2,100. The y on this case is going to be a little bit weird, but remember, the towers themselves are 500 feet tall. And it says here that the cable is 10 feet above the road at the lowest point. Alright, so 500 minus 10 is going to be about 490. Now keep in mind here, this is the origin. Everything underneath it's going to be negative, so it's going to be negative 490. So that is going to be your y value of the vertex. So here's your standard equation, and it looks like right here, if you notice, we have come up with a couple of x-intercepts. Let's use this one because it does have a number in there, 4,200, and let's put this into the general equation. Essentially, what we want to do is we want to solve for a in order to finish the equation off. We've got parts of it, but not all of it. So a y is equal to a, and we got x minus m, well, x minus 4,200. And then we have x minus 0, which is just simply x. Alright, and so now that we have that, what we can do is we can use our vertex. This is your x, and this one here is going to be your y. Now just plug that in where you see an x and a y. Y is going to be negative 490. Okay, we still have an a. This one here is going to be 2,100 minus 4,200. And then x, of course, is going to be 2,100. Okay, when you work this one out, what you have here is going to be negative 490 is equal to negative 4,410,000 a. And of course, we want to solve for a, so you have to divide this by negative 4,410,000. And you have to divide the other side by the same thing. Okay, and when you do that, you're going to find out that a is equal to 1 over 9,000. Okay, so this is the equation we got so far. We've got a, we got m, and we got n. And so what we're going to do is we're going to reduce it down and see if we get the equation that they said we were going to get in B. Okay, so what I would do is I would distribute this x first. It might make things a bit easier. In this case, what you're going to have is y is equal to 1 over 9,000. And in brackets, you're going to have x squared minus 4,200x. Okay, and then what you're going to do is you're going to distribute this within the brackets as well. And so what you're going to be left with is 1 over 9,000 x squared minus 7 over 15x. Okay, stating a suitable window for graphing the equation. Well, I'm not going to go through it entirely with you, but a suitable one that might be able to show everything would be something like this. For your x coordinates, what you're going to have is negative 10, 4,500, and 500. Okay, and then maybe for your y, you could have something like negative 500. That's going to be your minimum, and your maximum will be 10, and then your scale would be 100. Okay, so your values might be a little bit different from what I've shown you right here. The key is, of course, you want to see the most important parts of the graph. So for D, determine the height of the parabolic cable above the road 900 feet from the left tower. Well, on a calculator, it's pretty easy to do because 900 feet from the left tower, we're talking about the x-axis. So all you need to do is hit trace and 900, and what you should get is going to be about negative 330. And just letting you know, this is not necessarily the height above the road, because remember, the parabola right now, this right here is about negative 330, but what we want here is this part right here. So what you can do is take 500 minus 330, and you'll end up with 170 feet above the road. And in E, the equation of the parabola can also be written in standard form. Y is equal to a x minus h squared plus k. Well, we have a, and we've got the vertex, so it's pretty easy to do. Our a is going to be 1 over 9,000, as we've had before. Okay, and your vertex, if you recall, is 2,100 and negative 490. So that's going to be x minus 2,100 squared minus 490, because your vertex is 2,100 and negative 490.